Okay, picking up where we left off. We're going to use some derivatives every once in a while. So find the equation for the line that is tangent to the curve at -1,7. So we're going to hark back to when we did tangent lines in the previous section. For tangent lines, you need two things. You need a point, we got a point, and we need the slope. And so we need the slope at x equal -1, and we're going to recall, and if there was actually people in the room, I'd ask what we need to do, but there's no one in the room. I'm lecturing to an empty room. So we're going to recall that the derivative gives us the slope at a point. So in this particular case, my slope is going to be the derivative at -1. So what that tells me to do is to find f prime of x, then substitute in x equal -1. So f prime of x is up there. Multiply by the exponent, decrease the exponent by 1, derivative of coefficient times x, just the coefficient, derivative of that 2, constant is 0. So we get 3x squared minus 6. So my slope, f prime of -1, is going to be 3 times -1 squared minus 6 for -3. Then the equation of my tangent line. Just using the point slope form of the line. You get y minus y1 times m times the quantity x minus x1. And so I'm going to get y minus 7. Recall our point's up there, -1,7. So y minus 7 equals -3 times x minus -1. If all I ask you for is an equation of the tangent line, I will accept that answer, but we'll make it look a little prettier. So that's y minus 7 equals -3x minus 3, which gives me y equals -3x plus 10. Now remember, you can check these guys that talk about pictures, graphs. This is the equation of a tangent line. So we should be able to check it, and we are going to check it. So, you can sort of see it right there. Y equals, put in the original function, so x cubed minus 6x plus 2, and then put in our tangent line, and we got -3x plus 10. And then zoom 6 and see if it looks possible. Zoom 6 just being the standard window. And so there's my curve. And that's wrong. And I didn't mean to be wrong, so I've made a mistake somewhere. There are two places I could have possibly made a mistake. My calculations and where I typed, or what I typed. But that is clearly wrong. It is not a tangent line. So that is wrong. So first of all, I said -3x plus 10. Let's see if I have that in there. I do have in there -3x plus 10, so I think here's where I made my mistake right there. And this is why you want to check things. Honestly, I did not do that on purpose. But here's why you want to check it. That's wrong. And by checking it, I caught my stupid little mistake there where I added 7. This should be 4. There's why you want to check things. You make stupid little mistakes. So let's change that to plus 4. And hope for the best now. And there's my curve. And there's a tangent line, and that looks pretty good. I feel very confident about that answer. And if we do a trace and ask it to go to -1, the little blinking cursor, which you really can't see up there very well. Now, yeah, up there at the top. It's in there. Now let's maybe try to get a better picture because it was at -1.7, which is really near the top of the graph. So let's try to get a better picture there and really zero in on that -1. So how about we go from -4 to 1? So -1's more in the middle there. And then it was 7. So how about -1 to maybe 12? Zeroing in more on that point, -1.7. And if we graph that, there's my curve, and there's a tangent line, and that's a good picture. So now I know, almost certainly, I am right. But if I hadn't had the time to zero in on there, reset my window, even at the standard window, -10 to 10 on both the x and y axis, I would have felt pretty good by that. It obviously didn't look wrong like my first answer, so I'd feel pretty good about that. So there's the first one. Equation of the tangent line, -3x plus 4. Okay, working with this same function a little bit more. Find the points at which the curve has a horizontal tangent. Now we talked about that before. And the steps to horizontal tangent were this. One, find f prime. 2, set f prime equal to 0. 3, solve. So doing that, we already know that f prime, did it on the first one, was 3x squared minus 6. 2. Set that equal to 0. 3, solve. And so that's be 3x squared equals 6, x squared equals 2, x equals plus or minus the square root of 2. Little tiny algebra errors that maybe your algebra teacher didn't take off for will wreak havoc in calculus. When you solve an equation by taking the square root of both sides, you've got to include the plus or minus. Forgetting the plus or minus is actually a big deal because you're leaving off half of the answers. And so what we have right here are the x coordinates, where the tangent is horizontal. Which is not quite what they asked for. What they've actually asked for are the points. So we need the corresponding y coordinates. So y, if x is square root of 2, y is going to equal f of square root of 2, which is going to be square root of 2 cubed minus 6 times square root of 2 plus 2. And never, ever, ever give me decimals if I didn't give you decimals. So you cannot take your calculator out and tell me what decimal that is. I do not care what decimal it is. So this is square root of 2 times square root of 2 squared. All right, because it was cubed. So I just brought off one of the square root of 2, so square root of 2 times square root of 2 cubed. Minus 6 square root of 2 plus 2, which would be 2 square root of 2 minus 6 square root of 2 plus 2 for negative 4 square root of 2 plus 2. And so the point is square root of 2, negative 4 square root of 2 plus 2. Which for purposes of checking, which we're going to do now, and only for checking purposes, is approximately equal to, squiggly equal sign, approximately equal to. Approximately equal to 1.41 having trouble typing here, negative square root. Negative 4 times the square root of 2 plus 2 is approximately equal to 1.43, negative 3.66. Just doing that for checking purposes, not that you'd ever give that to me as a final answer. And x equals negative square root of 2. Same deal, y is going to be f of negative square root of 2. And you're going to do the exact same thing, but this time you will come up with negative 2 square root of 2 plus 6 square root of 2 plus 2 for 4 square root of 2 plus 2. Doing the exact same thing. For 4 square root of 2 plus 2, or the point, negative square root of 2, 4 square root of 2 plus 2. Now we can check this. When we did these guys before, we said that these were predicting your high and low points. So I'm going to go back to my graph of just my function. And we're predicting those high and low points. And we said at square root of 2 and negative square root of 2. So I'm going to do a trace. I'm going to zoom in a little bit so you can see that picture a little better. I'm going to do a trace. And I can trace to square root of 2. So trace, and then you can type in square root of 2. And it'll do it just fine. Hit enter. It goes to where that point is. That is clearly where the horizontal tangent is. And then down below it gives you an estimate of 1.41, blah, 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 and negative 3, 6.65, which I believe corresponds very nicely to the estimate I gave. And so there's the estimate, there's the exact answer. But here shows why, since I'm a math person, I want exact answers, which is why we need the calculus. Yes, my calculator very conveniently and very easily gave me a really nice estimate. It's a great estimate, but the exact answer is right here. And you always give me exact answers. Do not give me a decimal unless I give you decimals. I want exact answers. There's the exact answer. Now, you certainly should use your calculator to check your exact answers as we did here, but there's the answer. And then you could check the other one exactly the same way. And that's where we'll end this video.